All right, hello there. My name is Dorian. Today I'm just going to be running through the basic rules of IUPAC nomenclature. So that is how to name things like alkanes, alkynes, alkenes. Today we're just going to be dealing with an alkane that is basically carbon and hydrogen that doesn't have any double bonds or any substituents like oxygen or anything like that. So we're basically just dealing with carbon and hydrogen. Now there's a few different ways that you can draw these. I've decided to go with the skeletal format. You can see this more clearly on the image that I put on the side here. The skeletal format basically is just drawing this without any of the hydrogens attached to it, but basically what you should know is that every carbon is going to form 4 bonds. If you see one bond connected to a carbon, you're going to know that that carbon also has 3 hydrogen bonds. If you see 2 bonds to that carbon, you're going to know that it's going to have 2 hydrogen bonds. So you can see that more clearly up in the expanded format up at the top here. 3 carbons, then you've got the full ring of hydrogen surrounding it, which you can easily draw as well as a condensed format, which is just carbon and hydrogen 3, carbon and hydrogen 2, carbon and hydrogen 3. Over here I've got 3 carbons. Over here, line angle, that means that every point, so here, here, and here, represents a carbon. So this is exactly the same as this, just you don't even draw the carbon at that point, you just draw a line to represent them. So at this point here, what I'm going to be doing is helping name this larger molecule over here, which some people might find a little more complicated just because there's a few rules that you need to remember. First and foremost are the alphabetizing, numerical order, and how to name the substituents. And a lot of people actually even get tripped up just on naming the parent chain. So this is what we're going to do for this molecule right here. Naming the parent chain is going to be finding first off the longest chain of consecutive carbon atoms. Now, a lot of people might think, oh, you just go from left to right. So I'm going to go 1, 2, 3, 4, 5. That's not going to be correct because that's not actually the longest chain of carbons. What we're going to do is we're going to try and find which one of these is going to be the longest chain. So I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, there's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's another 10. Is there anything that's going to beat that? Probably not. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 again. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. No. So there's nothing else that's really going to beat that. So first thing that you're going to want to do, circle in that parent chain. So what I like to do is I'll just pick one of these because there's 2 different routes that you can go for 10. Doesn't really matter because this carbon is branching off with 4 after it. This one is branching off with 4 after it. Just pick whichever one you like. So what we're going to do is I'll just highlight this here. Now we have our parent chain. So if you want to be proficient, what you can do is you can actually just name that parent chain now. So we're going to go up to our parent chain naming. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What do we have here on our IUPAC prefixes? If it's 10, it's going to be dec. Now, because this one doesn't have any double bonds or triple bonds, this is going to be an alkane, which means that any of your parent chains are going to end with the suffix ane. So this one is going to be decane. So we'll just write that in here. Decane. So this is going to be the last thing in our name. Now we got to work around these substituents. So there's a few different ways that you can go about this. For the substituents, you could have, let's see, 1, 2, 3, 4, 1, 2, 1, 1, 1, 2. So the way that you go about choosing how to name these and how to put them all together is to remember a couple different things. One, every one of your substituents is always going to end with a ethyl, so ethyl, methyl, pentyl. So it's basically taking these IUPAC prefixes and we're just going to work out which of these fit with it. The other thing is that you're going to want to work out which way is going to make the least amount of total substituents. So there's a few different ways you can do this. If we started from this side, let's say we named our parent chain. I'm just going to show you an example. This is wrong, but it's good to kind of learn from the wrong way to do things, how you actually do it correctly. So let's say we name this one 1, and we name this one over here 10. What's going to happen is we're going to start from 1 to number our substituents. So 1, 2, 3, 4, 5. So we've got a 5, 6, 7, another 7, an 8, and then 2 9s. So if we add all these up here together, we got what? 14, 20, brain's not working right now, it's late. Give me a sec. 45. So that's a pretty big number. Let's try going from the other direction. So second carbon, we got 2. 2. We've got 1 on 3. We've got 1, 2 on 4. So 2 4s. And then we got 1 on 1, 2, 3, 4, 5, 6. So now we've got 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 versus 45. Obviously, we're going to go with this order. So don't rely on the orange color here that I've gone through. We're going to go instead with the red. We're going to name this carbon 1. We're going to name this one over here carbon 10. All right. So now we're going to go through and pick our substituents, and then we're going to put it all together as a name. Okay? So we've got a few things here. Any group that has just one coming off of it, that's going to be a methyl group. Now, what we want to remember is that you've got these Greek prefixes up here. So Greek prefixes are basically going to let us know, is it going to be a single group that's branching off? Is it going to be more than one group that's branching off? More than 3 groups that's branching off? It's basically a way of identifying how many of the same type of group we have on this chain, and we individually number them. So what we see here is 1, 2, 3, 4 different methyl groups. That's one pair. From those 4 different methyl groups, we're going to have to pick the tetra, which is going to be number 4. So tetramethyl. So tetramethyl. And we're going to want to number them as well. We got 2 on number 2. So 2, 2. We got 1 on 3. We got 1 on 4. Now, anytime we're writing the numbers in our name, we're going to separate them by a comma, and numbers separated from words by dashes. So this guy here is going to be 2, 3, 3, 4 tetramethyl. Now let's name this guy here. So that's 2 carbons, so we're going to name that one ethyl. That's 2. So there's only 1 there, so we don't have to call it di or tri, we just call it ethyl. So we're going to call that 1, 2, 3, 4. So this is going to be 4 ethyl. And finally, we've got this big long guy here. Now that's 1, 2, 3, 4 carbons that are branching off. We're going to call that bute. So butyl, there's only 1 of them again, so no prefixes there. So butyl group, that's going to be 1, 2, 3, 4, 5, 6. So 6 butyl. All right. Now we just want to put it together into a name, so alphabetize it. It's going to end with our parent chain name, and we're going to have each of the names of our substituents in front of it. Now they have to be alphabetical. Here's where a lot of people get tripped up. Tetra, or any of the other Greek prefixes, so di, tri, tetra, they don't count for alphabetical priority. The only thing that counts for alphabetical priority are these guys here, and occasionally when you get something called iso, that actually counts as well. But we're not doing that here. So each of these here, we're going to go, let's see, you got M for methyl, E for ethyl, B for butyl. So we can tell B's first alphabetically, then E, then M. So let's put those all together into a big old name for you. So we got 6 butyl, separate with dashes, 4 ethyl, 2, 3, 3, 4 tetramethyl, and then we'll just finish it off with our decane. So that's our whole name there. So we've got 6-butyl, 4-ethyl, 2,3,3,4 tetramethyldecaine. So on your handout that I've given you there, hopefully you've been able to follow along with that and get it sorted out on your own as well. But basically, that's what we were hoping to find, and I hope that made a lot of sense. We do find certain circumstances where these rules don't really make a lot of sense if you're dealing with double bonds and single bonds mixed with triple bonds, but that's basically just going to be the rule for any of these saturated hydrocarbons. That means fully saturated with hydrogen, right? If we threw in, say, for instance, a double bond right here or something like that, we would have to include that in the parent chain. If we had a double bond right here, we'd have to include that in the parent chain. So some of those rules do come into play, and we're obviously going to cover that up a little bit more the later we go. So I hope this was helpful. If you have any questions, obviously let me know, and I hope the handouts were helpful as well.